All right, as a warm-up, I ask you to try this one right here, all right? So if you're going to graph this, tell me the transformation that you see. Up 5. Be careful, if the 5's on the inside of the radical, it would be left 5. But this is on the outside, so it's up 5. All right? So we ought to have our phones and things put away. We ought to be ready to go. Okay? So we're going to go up 5. Now, as we've been doing these square roots, there is a pattern involved. What is the pattern for the square root? Up 1 over 1. Yeah, this is the notes where we left off yesterday. All right? Up 2 over 4. Technically, we could go the 9 and the 3. Okay? Now, I made mention of this yesterday, but we didn't do this yesterday, so that's why I'm doing this other one. What kind of line gets drawn here?
Dotted.
A dotted. Why?
Because it's not or equal to.
Yeah, it's just greater than. It's not greater than or equal to. If it's equal to, it's a solid line. So I'm going to draw a dotted line there through that. And then since it's an inequality, we have to shade. And where are we going to shade? Above it. So it's greater than. Y is greater than. So we're going to shade above. So it's this piece here. Again, remember, we're not shading all the way to the left because that graph doesn't even exist over there. Okay? All right. You're going to turn the page in your notes. We're going to skip a page or so there. And it's going to be, the next one we're going to be on is right here. All right. So if you notice on this one right here, you have these transformations. So this is the next page we are in our notes. So you got to turn the page, and I think we're skipping some word problems. We'll come back to them later. All right. I'm not going to have you fill this out because hopefully that looks very familiar, and we probably don't need to do that again. We did that on Monday. All right. So I'm going to skip that right there. We're going to talk about another graph today, very similar graph, but it's got a little bit of differences. We've been discussing a lot f of x equals the square root of x. So we've been talking about square root functions. We're going to now discuss cube root functions today. All right? And so if I was going to do that, I'm going to go build a table over here to help me a little bit. All right? So what would be an easy x value that I could put in there that I know the cube root of? 1. Okay? If I put 1 in there, the cube root of 1 is 1. Because 1 times 1 times 1 is 1. What else is another pretty easy one? 0. I agree. The cube root of 0. 0 times 0 times 0 is 0. All right? How about another one?
2.
Okay? Now, I think you're thinking backwards there. You're thinking the y value. I want the y value to be 2. What would the x value be if the cube root of something is 2?
8.
8. 2 times 2 times 2 is 8. So if I were to do the cube root of 8, that would give me 2. All right? So the next one, as we go to the next one, where would we go next? 27. We're going to make a big jump, right? So these are jumping pretty drastically. So the next one will be 27 and then 3. We probably would not do that one a lot just because it's a pretty good sized number. Okay? Now, on the square roots, we never really talked about the negative side because why? You can't take the square root of the negative number. Well, how about a cube root? What about the cube root of negative 1? Negative times negative is positive, but another negative makes it back negative, so it works. A cube root, it's an odd function versus an even function, so it works. Negative 1 works there. Same thing with negative 8. If I were to plug negative 8 in, how do I get that multiplying 3 times? Well, negative 2 times negative 2 is a positive 4, times another negative 2 is a negative 8, so negative 2 works. And so what we see here is that the negatives don't impact the cube root, but they do impact the square root. All right? So I can go graph these. Now I'm not going to graph all these. I'm going to graph the smaller ones. I'm going to take these points and let's go put them on the graph. So I have 0, 0. I have 1, 1. I have 8, 2. I have -1, -1, and -8, -2. So my graph looks something like that. Okay. What is the domain for this graph? All real numbers. Is there any number that you can't put in here and take the cube root of? Well, we put some really easy ones, correct? But I could use my calculator and get some assistance and pick decimals. I can pick negatives. Anything works here. So forever to the left, forever to the right. All real numbers for the domain. How about for the range? All real numbers as well. Now, how quickly is this graph increasing? It's not. It's not going up very fast, but it's going up. All right, it's just going to take a long time. For instance, to get to 3, to get to a y value of 3, it's going to take me 27 spaces on the x to get there. But it's going to get there eventually. All right? It's not very quickly. Now, in this graph right here, in the square root graph, we had a starting location. We had a starting point. All right? That was very helpful for us. In this one, we have what we refer to as an inflection point. The inflection point is that location right there. It's where this graph is kind of turning. The graph kind of looks like it's kind of going up and then kind of turns, and the shape of the graph kind of changes there at the inflection point. So our inflection point for our parent function is 0, 0. Okay? So cube root graph, it looks a little bit the same, but then it's got a different piece as well. All right? Because of the nature there. Now, if you slide across the page, we've talked about this the other day. We had an f of x, and it was x squared. And we had a g of x, that was the square root of x. And we didn't really talk about the parabola a whole lot because we had talked about it before. But I want to discuss this. I want to discuss x cubed. All right? So if we were going to do x cubed, if I was going to build a table right here for x cubed, because this is the parent function right there. What would be an easy value to plug in there in cube? 1. 1 cubed is 1. What else would be another easy value? 2. 2 cubed is 8. How about 0? It's my favorite one. All right. 0 cubed. What about -1? What's -1 cubed? -1. Because 3 negatives make a negative. And -2 cubed would be -8. What do you notice? It's just flipped, right? It's the same table that we just did, correct? So this is a cubic function is what we're doing here. That's a cubic function. And this is a cube root that we just did just a second ago. All right? And what we notice is that if we're doing the parent functions, it's the same points. They've just been flipped. What do we call that? An inverse. That's correct. So cubic and cube root graphs are inverse graphs of one another. All right? So if I know one, then I know the other. I know a lot of characteristics about that. So if I was going to graph this one, I'm going to start at 0, 0, 1, 1, 2, 8 kind of goes off the graph a little bit. It's up there. -1, -1, and -2, -8. And you have that graph there. What about the domain on this one? All real numbers. Is there any number you can't multiply by itself 3 times? No. All right. All real numbers. And my range here? All real numbers as well. It looks like it's going quickly to infinity and quickly to negative infinity. All real numbers also. Does the shape of those 2 graphs favor? The shape kind of looks the same. Kind of looks like it's been flipped or turned a little bit, right? But it looks a lot the same. So let's try this next one. So if this is my f of x, if this is the cubic graph, then what transformations do you see on this one? Left 3. Looks a lot like a parabola, correct? Now be careful, it's got that cube up there instead of a square, that's the difference. But we are going to move left 3. So I'm gonna take it, I'm gonna move my inflection point, it's gonna go left 3. So my inflection point's gonna be at -3, 0 now, okay? -3, 0 is gonna be my inflection point. I'm gonna use my pattern. My pattern is 1, 1, 2, 8, -1, -1, -2, -8, and I get that graph there. So domain, all real numbers, range, all real numbers. By moving it left, did it change my domain range? Is there gonna be a transformation that's going to change my domain range here? Probably not, right? I could flip it, I could stretch it, I could shift it, but it doesn't look like anything's gonna change it, okay? What transformation would you see on this graph here? Up 2. It's not in the parentheses, so that's up 2. So I would have my inflection point there. Over 1, up 1, over 2, up 8 would be off my graph. Over 1, down 1, over 2, down 8 would be right there at the edge of the graph. And then I have that cubic right there. And again, like you said, we discussed just a second ago, all real numbers would be my domain, my range. Okay? So, in order to understand cube root graphs, you kind of have to understand cubic graphs a little bit as well. All right? So we'll mix and blend both of those in here over the next couple of days. All right? If you go to the next row, we've already done this one. I'm going to sketch it real quick. This was the cube root, and there was the parent function of the cube root. So 0, 0, 1, 1, 8, 2, -1, -1, -8, -2. All right? And that graph looks something like that. That was our cube root function. We said it was all real numbers, so I have that. So now what I want to do is I want to take this and I want to move this one around. Okay? So, again, what is that transformation right there? Left 3. So if I were to write that in a cube root format, because g of x is cube root, then the x plus 3 would go inside that radical. It would be underneath the cube root symbol. I'm going to move left 3. So instead of being at 0, 0, I'm going to be at -3, 0 would be my inflection point. And I'm going to use my pattern. 1, 1, and then 8, 3. Excuse me, 8, 2. -1, -1, and -8, -2. So there is that graph. Domain still all real numbers, range still all real numbers. Okay. For that next one, what I want you to do is I want you to rewrite the equation for me. Write it in the cube root format. So take the transformations that they were given, and let's rewrite that into cube root format. So if I were to do that, what goes underneath the radical? X minus 2, and the plus 5 goes there. What does that mean for me as far as transformations? Right 2 and up 5. Right 2, up 5 puts me right here. So that's where my inflection point's going to be. Over 1, up 1, over 8, up 2 would be up there. Over 1, down 1, over 8, down 2 would be there. And so there is my graph. Looks like that. All right? Again, moving it left and right, the domain and the range ought to be super easy for cubic and for cube root graphs. All right? Pretty easy to do there. All right? I want you to try this next one right here, the one on the bottom left there by yourself. Try that one. Sketch that one, write the equation for it. Sketch it.
Is this inversing or just as is?
Do the g of x, which would be the cube root one. All right. If I were to rewrite it, it'd be the cube root of x minus 2 plus 1, which means I'm moving how? right 2 and up 1. Let's move it right 2 instead of just 1. Right 2 and up 1. There it is. Over 1 up 1. Over 8 up 2. Over 1 down 1. Over 8 down 2. And there would be that graph. Okay? My inflection point, if they asked me to write that, my inflection point would be 2, 1. That's where the important or critical value of that graph is. Okay? I think you need to turn the page, go to this next one. So it's the next page. It's got several graphs again. Kind of looks like what we've just been doing. Turn the page on that one. All right. I'm going to skip the entire first row. I'm not worried about that. We'll come back to it. I'm not going to do this first one here either because we've already done the parent function. But let's take a look at this one. So this is right in the middle. All right. It's the middle of the tic-tac-toe square. All right. What transformation is this that you see? It's a reflection. All right. What type? Over the x. It's a vertical reflection. And so this negative would go out front of the cube root. Now, if I were to do this real fast, 0, 0, 1, 1, 8, 2, -1, -1, and -8, -2. All it is, put the points there. That's my normal graph. That's my parent function. If I'm going to vertically reflect it, can I vertically reflect 0? No, so it stays put. If I vertically reflect this one, it goes to there. If I vertically reflect that one, it goes to here. This one goes up, and that one goes up. And so there's where this graph would be. What do you notice about the slope of this graph? It's negative. As I start from the left and go to the right, what's this graph doing? It's going downward. It doesn't technically have a slope, but it's decreasing as I'm going. All right? And so that's kind of a part of that negative that's out front there. All right? All the other graphs we've done so far have gone up. They've increased. Again, this doesn't change my domain. It doesn't change my range. Still good there. My inflection point's pretty easy. Still, it's still at 0, 0. All right? How about the next one? How does this one impact my graph? What transformations do you see there? Okay, we got a vertical stretch by 2 and up 1. So we're going to go up 1. So there's up 1 right there. If I were to write this in form of the equation, it would look like that. The 2 would go out front. And have cube root of x, and then the plus 1 would go after. Now, our pattern that we've been discussing has been 1, 1, 8, 2, 27, 3. Hopefully we don't have to do that one. Yes, sir?
How is that a vertical reflection if it's directly multiplying with the x?
Vertical stretch.
Stretch.
Yeah, vertical stretch. All right. Because it's on the outside. If it were on the inside, then it's going to do horizontal. So that would change the x.
Parenthesis?
Well, there's no parentheses here, but what the parentheses are the radical. All right. So if it's inside the radical, that's inside the parentheses. It's inside the function.
Okay.
So that's what's happening there. On the old calculators, if you push this cube root in, it would open a parenthesis for you, which kind of shows you that it's a parenthesis. All right. And so anything inside the radical is inside parentheses. So on this one, since the 2's out front, since it's not in the parentheses, it's a vertical stretch, which means all the y values are going to change. So those y values are going to change by 2. All right. So I'm going to go, instead of over 1 up 1, I'm going to go over 1 up 2. Instead of going over 8 up 2, I'm going to go over 8 up 4. So if you notice here, this graph is growing a little bit quicker than the previous one. Doesn't change a whole lot there, but it does. It looks like it's growing a little bit faster. Again, my inflection point would be at 0, 1. My domain and my range would be all real numbers still as well. Let's try one more of these. I'd like you to try the one on the bottom left there. Why don't you try this one right here? Put it up there here in a second. If I were to rewrite this, this is what it looks like. All right, we have a negative out front. We got the cube root of x minus 2 would be inside the radical or inside parentheses. And then plus 1 would be on the outside. Which means, how is my inflection point moving? Right, 2 up 1. So there's my inflection point at 2, 1. All right? My pattern is over 1 up 1, except I have a negative. By the way, on this graph, if I flip left and right or flip up and down, would it matter?
For the starting point?
No.
Or just in general?
Just in general. So, like on this one right here, we flipped it, correct? And we flipped it, this was the original. We flipped it up and down because that's what it said to do. But if I had flipped it side to side, would it have been the same?
Yes.
It would have been the same in this one. Now, that's not always the case. But in this case, the horizontal reflection and the vertical reflection are the same, right? Was it the same with square roots? No, they looked a lot different, right? Mainly because of the domain and stuff on that one, right? So on this one, I've got to flip it, and so over 1 down 1, over 8 down 2, over 1 up 1, over 8 up 2, and my graph would look something like that. Okay? All right, let's do one last problem. So if you slide over there to the right, you have a picture of a graph for you already. So I believe it looks something like this. So I want you to take a look at the graph. We're going to go work backwards on this one. So they gave me the graph. I'm writing the equation now. So take a look at the graph. Let's see how it's been moved. How's it changed? All right. Any thoughts? How has this graph been moved from my original one? Yes, sir.
Up 3.
It's been moved up 3. Okay. Because it's supposed to be at 0, 0. And now it's at 0, 3. So it's been moved up 3. Good. Is there any reflection? That would be really easy to see, correct? Because if it's a reflection, it's moving downward as I'm going through the graph instead of moving upward. So there doesn't look like there's a reflection. Doesn't look like I've shifted left and right. All right. But we do have to check. Somebody said, is there a dilation? Is there a dilation in this problem? No. How do you know? Count it. Over 1 up 1. Over 8 up 2. Over 1 down 1. Over 8 down 2. It looks like it's hitting that. So my normal pattern looks like it's good. So the pattern didn't change. So all I need to include in this one is the up 3. So if I was writing an equation, by the way, it says write an equation. If it's an equation, what do you need in your equation? An equal sign. A y equals or a f of x equals or something like that. I don't care which one you put. Y equals, f of x equals, g of x, whatever. Cube root of, where does the plus 3 go?
Outside.
On the outside. So it would go there. So that's what I would have. Okay. All right, so that's where I'm going to end today. What I'd like for you to do is I'd like for you to grab your homework packet. We've got about 12 minutes remaining in class. I'm going to give you some time there. So if you open it to where it looks like this, where you got like 18 graphs on one page, and then you've got some more graphs kind of on the other page of it as well. Okay? All right, so here we go. On the page with 18 graphs, I would like you to do 5 of those graphs. Okay, pick 5. Please do not pick number 1 on either side. All that is a parent function. That won't help you any. All right? So pick 5 on that side. All right? If you were to flip the packet over, if you notice there's 6 graphs that they've already graphed for me. Okay? I want you to write the equations for 2 of those. Okay? So there's 6 graphs that they've already done. So I want you to write 2 of those. And then 7 through 10 gives you transformations. I want you to write 2 of those equations. So looking at the transformations, write 2 of those equations there. Okay. So I'm going to give you the rest of the time to work on that. I'll walk around if you need some help. So we're graphing 5 on that one page. It's got a lot of graphs. Writing 2 equations, writing 2 equations. All right. Tomorrow I will not be with you. I will be gone. All right. We're gonna solve like we did on Tuesday. We solved square root problems on Tuesday. We're gonna solve cube root problems tomorrow. It's gonna be very similar. It's not gonna be a lot of different work. Couple little bit of differences, but it's gonna be pretty straightforward like Tuesday was. Okay. So that's what we'll have. So I'm gonna give you the rest of the time to work. Be quiet a little bit.